We are in the home stretch, people, and we are actually ahead of schedule, shockingly. So our next speaker, Jacob Lissy from Grafana Labs, will be giving a talk on what Kubernetes looks like. So let's see, where is Jacob? Oh, he's still in the back. Oh, wow. So in the meantime, does anybody have any questions about IveQL or influx data that I could answer? Right here. The question is when is IveQL coming out? When is production ready IveQL coming out? That is a good question. Right now it's a separate binary that you can run that connects with the database. So the risk of running it is actually a lot less than it would be if it were integrated with the database. So if you wanted to run it in production now, that'd be a bit adventurous, but you could because you can isolate it from the database itself. And we'd appreciate the feedback and the testing. We're going to be running it ourselves in production for our own monitoring infrastructure within, I'd say, the next 30 days. And then locking down the language and everything like that. And like I said, we'll have it available as an officially supported production binary that you can run with our enterprise stack in the summer of this year with the Enterprise 1.6 release. So, yeah.
How does it query if influx caches initial data in memory? How does IveQL get to it?
So the question is, if influx caches initial data in memory, how does IveQL get to it? So there is a new service that runs inside InfluxDB. If you look at the IveQL repo, it has instructions for how to enable it. So there's a separate service that runs, it listens on a TCP port. I think 8082 is the default one. And it uses just like a TCP TLV connection. Right now it uses protobufs to communicate. So the IveQL daemon can connect there and send queries to the database. And basically, like, the database doesn't process the entire query, it processes some subset. So like the filter and the range functions actually get pushed down to the storage tier. So it will look at those, it'll take the data that's in the cache, basically what Ryan referred to earlier as the in-memory record store, and combine it with the on-disk columnar store to return results. So basically, as soon as you write data to InfluxDB and the client has gotten a response, it's immediately queryable either in InfluxQL or IveQL. So, all right, I have wasted enough time up here. So, please.
One more.
One more question? Oh, okay, sorry.
Like Chronograph or Grafana support.
I should walk away from that. Chronograph or Grafana support. Hopefully Grafana support soon, but we've still been trying to work out we need to get, we're close on the language in terms of locking down what the syntax looks like. The last major change was the addition of the pipe forward operator, but we just cut that release on Friday. So we didn't want to send it over to the Grafana team and have them waste a bunch of cycles like doing stuff that was constantly changing, and the same thing with our own team. So I'm hoping that we'll be able to work with the Grafana team to get something going, soon, because the syntax is locked down. The one thing we do have to lock down is the request and response format, which we intend to do, I'd say, over the next 2 weeks. So once we've done that, we're going to have the Chronograph team kick off some work internally on it. So I'm guessing within Chronograph, I would hope we'll have something within 60 days, but I don't know. It kind of depends. And then Grafana, hopefully we can get something to them that they can work with that'll be consistent on the API side of things, like I said, in about 2 weeks from now, and then it just depends on how fast they can crank out the code. So, all right, welcome, Jacob.
All right, can everyone hear me? Cool. My name is Jacob Lisi. I work for Grafana Labs. I'm a software engineer on the Grafana Cloud team. A lot of the work I do relates to getting Grafana Cloud to work well with Prometheus and Kubernetes. We have a number of Kubernetes clusters internally, and pretty much all of our infrastructure runs on Kubernetes. So just a show of hands, how many people use Kubernetes? There's light, so I can't really see. Sorry, and how many people are like familiar with what it is? Because I don't want to get too bogged down in like explaining Kubernetes for those who already know. So what is Kubernetes? Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. That's a really dry sentence, but basically, Kubernetes allows us to think about deploying our applications in terms of compute and storage and a lot of abstract terms rather than managing what node is application X or Y on. It allows us to deploy things in abstract concepts called pods, and then pods are orchestrated through larger concepts like deployments or replication controllers, various other things, daemon sets. And these are basically just ways that are repeatable and configurable about how to deploy applications. So the thing that this talk is going to focus on is how do we monitor Kubernetes? So people who have Kubernetes clusters at home, there's a few tools that you can use to get metrics out of Kubernetes. So I just want to clarify for a second. I'm not going to be talking about your applications inside of Kubernetes. If you run random Java application X and you want to get your metrics out of JMX, you figure that out. You can do it your own way. But in terms of Kubernetes, there's pretty defined and standardized ways to monitor your cluster. And that's what we're going to be talking about today. So I'm going to start with saying that if you have a Kubernetes cluster, I highly recommend you use the Prometheus endpoints built into most of the tools already there. And honestly, take advantage of the Prometheus service discovery library that is part of the open source GitHub repo. It is very configurable. It will basically hook into your Kubernetes API, find the endpoints, and scrape them as needed. So if you aren't familiar with the Prometheus metrics endpoint, basically it's an HTTP endpoint, but you can use a number of different formats. There's a text-readable format, but there's also a compressed format. And Prometheus, or whatever agent you choose to use, will go and scrape that endpoint. And the format is metric name, and then a vector of labels, and then a value. And the timestamp is actually is gathered at scrape time. So one thing that a lot of people do when collecting metrics from Kubernetes is there's a concept called an annotation, and we'll talk about them a bit more later. But you can annotate your deployments on Kubernetes or in your static configurations, and Kubernetes can hook into these annotations and basically find and retrieve retrieve metrics itself. So the configuration is very minimal once everything's all said and done, especially because every kubelet already has an API endpoint for Prometheus. So every kubelet comes with a /metrics endpoint. That's built off of cAdvisor. Kubelet basically has a hacked up version of cAdvisor, which is basically a bunch of tools that gather system metrics that Google thinks are important for monitoring containers. So every kubelet will have that out of the box, and pretty much every Kubernetes cluster, these are metrics you're really going to want. The key kubelet metrics you're going to want to look at are startup latencies for your pods, because in terms of that's a very good indicator of how healthy your cluster is. The faster a pod starts up, that means that you have extra compute and things are reacting quickly. So the next thing I want to talk about is the Kube API server. So this is the actual control plane for Kubernetes. It also has a Prometheus endpoint. The metrics that you want out of there that are very helpful are are the latencies for requests to the API server, and that's also a very good indicator. So there's three tools that actually aren't necessarily standard, or two tools that aren't necessarily standard. The first one is the Kubestate metrics tool. So this is a tool that you can deploy into your Kubernetes. There's a bunch of deployment configurations that are already available on the internet. Just go up there. If you look up Kubestate metrics, I think the repo has a way to deploy it, or a deployment file. But what this will do is it's built on a client library in Go, and it'll actually hook into your server and get a bunch of information about the specifications currently running in your Kubernetes cluster. So you only need to run one Kubestate metrics container on any given cluster, and it'll hook into your Kubernetes cluster, and it'll get information like the number of pods running, like the label information for those pods, the number of restarts. I mean, we're going to show some dashboards later that make heavy use of this exporter. The other thing you have to do is I highly recommend you monitor your etcd. Etcd is kind of a backbone tool for Kubernetes. Without that, it will just not work, and you want to make sure that the latencies on that are low, or else you'll start noticing problems elsewhere. And then finally, node exporter, or whatever tool you want to use. But at the end of the day, your Kubernetes is running on hardware somewhere, and that hardware has a Linux proc file system, unless you use Windows, which you might, I don't know. But so you're definitely going to still want to monitor your node. Good old-fashioned like server monitoring has not just gone out of fashion. It's still there. It's just in a different niche, and it's used to support other things. So I highly recommend you still get proc information from your Linux file systems. And then there's certain things about Node Hub that you won't be able to get from the cluster that you're going to want a node exporter for. So like things like the number of TCP connections, file systems, because you may have file systems that aren't necessarily exposed to the kubelet, but you want to get information on them. So things like that. I mean, like, you never know, temp might fill up and your node will crash, and that could mess up your cluster. I'm going to start talking about a lot of people ask questions like, what should I monitor with Kubernetes? I think one thing you should definitely monitor is the SLOs that the Kubernetes scalability team has set out itself. So there's actually 2 SLOs that Kubernetes has put out. And like these are basically service level objectives that they think they want Kubernetes to meet, and like that's up to their standard of how Kubernetes should perform. I'll be honest, these SLOs are pretty strict, but Kubernetes, you'll have to find a very big cluster with a lot of duress to find one that won't meet the SLOs. It does a very good job. It's a really well-written application. So this is some of the metrics that meet, like that's 90th percentile. Technically, it's 99th percentile. But this is pod startup latency, 90th percentile for a number of pods on a server. So a lot of them are pretty low, under 1 second. You see some are above 1. A lot of that's probably to do with image pulling. Technically, the SLO doesn't include the time it takes to pull the image from GitHub or wherever you store your image, Docker Hub or whatever. A better way to view this is percentiles in a bar graph. So as you can see here, this is the pod startup latency on a QA cluster I have somewhere. So the average pod startup latency for this cluster is 7 milliseconds, which is far below the 1 second SLO. Granted, this is like only like 10 nodes, but still, it's a pretty fast time to containers, like for the pod to start. The next thing you're going to want to monitor is the API call latency. So this is the calls to your control plane. So as we know, Kubernetes has a control plane. It's a CRUD REST API, and I'm going to discuss that a little bit more in a second. But when you apply, when you post a request to this control plane, the faster it responds and the better the latency is, the more reactive your cluster is acting, and it's a very good sign of the health of the cluster. So I recommend you get this is also a 99th percentile latency. So as you can notice, this is in a logarithmic scale, and some of these latencies are super high, and that you would think, oh, that's pretty bad, but those are watch endpoints. So like those actually are streaming. So you would expect the latencies on those to be much higher than other tools just because they don't close the connection. So the next thing I want to talk about is Kubernetes metadata. So when we have Kubernetes and we're deploying a bunch of different pods on a bunch of different nodes, you're going to need a way for your organization to basically get a grip on this information. So there's 2 internal mechanisms that Kubernetes has for this. The first one is annotations, and these are more machine readable. So when I showed you earlier the Prometheus.io/scrape, that's the best practice for when you're running Prometheus. That's an annotation that you would apply to your pods or to your deployments or whatever for Prometheus to find them and scrape them. So that's a machine readable key value. The next thing you would want is labels, which are human readable. So these are going to be metadata that you want people in your organization that makes sense to you. So every organization has different labels. Some of the common ones would be node name, the owner of the application, the owner of like who supports it, random tags that mean very organizational specific things that anyone outside the organization wouldn't really realize. So that's where you would want to put that kind of stuff. And this stuff gets more important later because when you're talking about monitoring Kubernetes, these are metrics and these are dimensions that you're going to want to be able to query metrics on. So when you query a metric, you're going to want it specific to your use case. You're going to want it specific to what your team is monitoring. And this metadata is where that comes into play. So with Kubernetes, I'll be honest, it generates a lot of metadata. Especially compared to older paradigms where you have a more node-focused operation, specifically because back in the day, when you just had servers that had one application on them, or two or three, your node name didn't change. You didn't have UIDs like that explode in cardinality like you do today. Today, with Kubernetes, you could have a new pod generated every second, like every half a second. And that's a new UID, and that's cardinality that's going to fill up your time series database. And it's kind of anyone who's worked with a time series database knows that the more cardinality and the more dimensionality you have to your metrics, the longer queries take, and the more difficult those types of things become. So let's talk about in the past what metrics used to look like. This is how things used to be in Graphite world. You would have a CPU and a system, like you would have a metric CPU.system and host before it. That would be what you ideally would want. That's what everyone thinks of when they think of, oh, Graphite metrics. But there were some issues with Graphite metrics. Speaking from experience, I noticed every organization would start appending tags that made sense to their organization. But they wouldn't necessarily make sense to people inside of the organization. There would be specific tags and implicit tags that in a Graphite metric that make sense to certain people, and they needed them on every metric, but then other teams would be confused and did not necessarily know what that is, especially in larger organizations. And this is actually a pretty banal example. Like, this is pretty benign, and most people can make sense of this, but you got to realize, like, a lot of these things aren't necessarily named as clean as network. There's a lot of unfriendly characters in a lot of these namespacings. So a lot of that started to become organizational problems that had to be solved, which are much tougher than solving technical problems. It's very easy to get a metric and store it in a database and be like, this is this and this is that. It's much tougher to get everyone to agree that this is the format and have everyone on the same page and keep the documentation up to date. So I think one issue that we had in the past with Graphite namespacing is the problem would turn to an organizational problem, and that was much more difficult to solve for large organizations, and monitoring would become a second-class citizen as a result. And that's not to mention the fact that, this is a few agents, but every agent had a different way of naming things, and every organization or even teams within organizations would have different tags in different spots. And unless you had someone really strict in governing this, it would become very difficult to manage these kinds of things across a broad organization. Now, I'm talking about this just because Kubernetes has taken a pretty firm stance of packaging metrics within the application. Like, the kubelet has an endpoint. The API server has a metrics endpoint. The etcd has a metrics endpoint, and they're all in the Prometheus format, which is not an implicit tag format. The Prometheus format is a metric name with a vector of tags. Now, the advantage to this is that when you query an explicitly tagged metric, then you get into a situation where if I don't have to know anything about the order, if my tag stays the same, I know it's the same. Like, I'm not worried about any other tag in my metric. I know what my service is called or my host is called or what I want. I don't care if there's other tags there. Whereas with Graphite, you have to consider those other tags because they're part of your metric, and you have to see them every time you query. So this is great and all, but at the same time, there's still issues. We still have the curse of dimensionality. So the curse of dimensionality is basically a term when you talk about combinatorics. God, I can't even, so I need a water. But So when you have combinatorial problems, you end up in a situation where as you add more and more tags and more labels, technically an O of 2 to the number of dimensions is not true. Like there's things you can do like reverse indexes and a lot of things to make that a different big O. But once you start adding functions on top of that, you still run into a lot of the same problems. So one thing that with Kubernetes that I want to talk about is we don't want the dimension in the time series database. We don't want to explode the cardinality inside of the TSDB. What we'd rather do is keep the dimension in the use the dimension in the control plane and create extrinsic tags that you can use to query when you oh, thank you. Oh, no, sorry. I appreciate it. So when you and another thing when you have explicitly defined tags in a vector is there's a desire to maintain consistent metric tags. So if I have a metric that's node CPU, I don't want a label in the vector for that metric that's different from other metrics of the same name. So if I have two hosts and I have CPU metrics for both, I'd want the tag for both to be host, but I don't want one to have a tag that has service and the other one not to, because then when I try and aggregate across queries, then some of my metrics don't work. I end up in situations where there's edge cases where I don't actually have that label value when I try and aggregate. You want your metrics to be as consistent as possible across their dimensionality as long as they're in the same namespace. So if I have a metric that means the latency of service X for a request, I want the labels for that metric to be the same across all of those services. I don't want some to have tags and others not to. You want to put that dimensionality elsewhere. And keep in mind, when you're dealing with containers and pods and all of these things in Kubernetes, they're ephemeral and they're going to go away. So don't worry about what a container was doing a week ago. You may want to worry about what the application performance of a week ago, but don't necessarily worry about what pod X or pod Y was doing. Worry more about the aggregated metric. So the thing I really wanted to talk about is we've done some work on Grafana to allow you to use extrinsic tags and use the Kubernetes API as a data source for template tags. So what this allows you to do is query on tags and labels that don't really belong in a time series database and are ephemeral, but have that ability on query time when you're doing visualizations. So we've implemented a few so far. Over time, we want to do more. And I want to show you guys that right now. So I have an instance of Grafana running on my local host. The Kubernetes app is here. It's open source. It might be private. I'll change it if it's later today, I promise, if it is. So we've had this for Graphite for a while. Not many people used it, and not many people use Graphite to monitor Kubernetes. And there was also issues where there was aspects to the application that weren't transposable across different dashboards. But we've changed that and updated it, so now you can use a lot of the features that we've added and a lot of the custom panels across any dashboard. So I have a Minikube running with a number of applications, I think. I'll show you a different one then. So I have a QA cluster running with a number of applications. And as you can see, this is just the base of the application. It gives you very large overviews. The TLS on this needs to be replaced. But if we can dig down a little deeper, so this is the cluster dashboard. So I talked a bit earlier about the kube state metrics exporter. This dashboard, a lot of these metrics are based on that exporter. So as you can see, like the number of pod usages, we get that information from that exporter. That's a really good exporter to have because it gives you a very good idea of how your pods are, like how many pods are running, how many containers are running, just a good idea of the state of your cluster. That's why it's called kube state metrics. So this is one of our simpler dashboards. The next one I wanted to show you would be the node dashboard. And that has a nice list of the nodes in the cluster. You can click if you want to drill down, and you can go. You don't want to do them. There's a toleration thing, so if you click the masters, we don't actually have metrics on those. But see this minion, you can get more metadata about the node, and then we have a pretty basic dashboard. But this is just one dashboard. You can take this node drill down and use it anywhere. So that's the exciting part about this. The idea that we can start using metadata from the Kubernetes API server. You may not realize this, but these template tags on this node dashboard is not being queried from a time series database. It's being queried directly from the API server. So we've added the Kubernetes API server as a data source that you can use for template variables, which will allow you to query on things that you otherwise wouldn't necessarily want to query on or have in your time series space in general. And by that I mean like very random annotations and dimensions that you don't necessarily want existing inside your time series database, but you do want to be able to query on or view in real time. So this is a pod dashboard. If you want to talk more, I think pods aren't not necessarily supposed to be viewed like this in larger clusters. I have different recommendations that you're going to want to do aggregations because in a large enough deployment, you're going to have too many pods that it's not going to make sense to view in a pod-specific way in very large deployments. You're going to have thousands, and there's no one in their right mind who can actually visualize thousands of time series. Like, you're not, unless you're like a machine. But the ability to have random annotations as a query parameter. So, for instance, this Grafana K8s app annotation. This is an annotation I added to some of the components that we use to get these metrics. So as you can see now, we have the node exporters we use right here, and the kube state metric pod. And we can see the total memory usage of each of these pods, the CPU usage, and it's pretty easy to drill down just like that on pretty abstract and arbitrary labels and metadata. And as you can see, like, you're not going to want metrics with 20 or 30 labels in it, but you are going to want to be able to filter down pods and query on them in random situations. So that's what this allows you to do. All of these template variables at the top are also populated from the Kube API. There's nothing stopping you from using the Kubernetes data source with any time series database as long as the pod or the namespace or the node name is the same in the label that you're using the template for. So this is something that anyone can use with any data source. It's a really nice way to get started and have a good idea of how your cluster is running and get a handle on the metadata within your cluster. So then let's go back to my slides. So the reason this is easy to do and we want to expand on this is Kubernetes has a very well-defined API. It's a REST API. The metadata structures are identical. And this allows us to utilize this across every single Kubernetes resource. There's no reason that we can't have every single resource within Kubernetes as a template tag that can be queried, and you don't have to even bother storing it, and it'll update as it changes. So you don't have to worry about the tags changing. You're getting it directly from the source and using it to filter down on other resources within Kubernetes that are in your time series database. So over time, we plan on having pretty much every single workload or cluster resource that makes sense as something that you can use and query on and get template tags on without actually having them stored within your metrics. As long as you have something that you can filter down to, like a pod UID or a service name, something like that, you can use extrinsic tags to basically narrow down the number, like what pods you actually have to query for, and auto-generate a template tag that will go into your query. And then one really exciting thing is custom resource definition. So many people may not know this about Kubernetes, but you actually have the ability to extend the Kubernetes API to have your own objects and your own resources that fit your organization. So if you have a custom application that makes sense to extend Kubernetes and you want your end users to kube control, create infrastructure component Y, you can add that into the Kubernetes API and manage it using the API, and then also get tags from it and template query parameters for your Grafana dashboards or anything really. So it's not that special to be able to get metadata from the Kubernetes API into your Grafana dashboard. but I think it's more than just that. I think one thing that's really exciting about Kubernetes compared to previous open source tooling is that because Kubernetes defines the name of the metrics, Kubernetes, the application itself is what's defining the infrastructure is defining the metrics. The infrastructure is defining the labels. As long as we keep the common standards in place, we're going to be able to do stuff with open source monitoring for free that we weren't able to do in the days when we had implicit tags that didn't really exist across every organization. Not every organization had a different metric for CPU. Every organization had a different metric name for file systems. So it was very hard to make turnkey solutions. Things that you would get out of the box from some paid services with their agents and auto visualizations and auto-generated alerting rules. That was something that was very difficult to do in an open source manner across across open source tool sets. But this is different with Kubernetes. With Kubernetes, the standards have been defined already. We have a very strict regulated API. The metrics so far are pretty consistent. I mean, as long as it keeps going in this direction, we can make a world where Kubernetes is commoditized monitoring. Like, we don't know, it's not something that people have to think about. It's just out of the box. It manages itself. And that's really the goal, not to have a world where every organization has different metrics and every organization has a different way of doing things, but just make monitoring Kubernetes boring. And that's really what I wanted to talk about today. And I hope you guys enjoy my talk. So if there's any questions, feel free to ask. Start on the left side. Oh, where are we going? You.
Quick question. So if the Kubernetes is the data source, so how much of the back data do you have, like historical data?
Kubernetes doesn't have time series metrics. It just has metadata. So it'll be what exists in the Kubernetes API. When you kill a pod or when a pod dies, you can still get it technically. But that's actually something that's configurable within Kubernetes. So that'll be something that the Kubernetes team itself will manage.
So basically what you're offering is that use the Kubernetes as the metadata to create the real query against the InfluxDB that has the metrics stored, and that's basically what the basis for the example dashboards are.
Exactly. And basically, the way that what I showed you worked, the way it worked is the metadata is derived from the Kubernetes API, and then we use that to filter a list of pods that's derived from the Kubernetes API. So we use the Kubernetes API to create the list of labels to query for the template tags. So that's basically what it comes down to. So then you can basically get a list of pods that have metadata and labels you don't necessarily want to keep in a time series database. Or like you may, so just to keep the dimensionality of your metrics lower and keep query performance up. Yeah. No problem.
Hello.
Hello.
So continuing on from that question, if that's the case, and let's say I have a name label on my pods
Yes.
to specify the service that they're in, and then I roll out a whole new set of pods, like I upgrade the deployment, is it the case that the old pods are not going to now be included in any queries?
So there's ways you can get the old pods, and like obviously there'll be a drop off from the metrics. Like those pods will no longer be showed up. You can get those in the queries, but there's a way in Kubernetes to get pods that are no longer running and get the names from them. But you can also call that metadata as well.
Yeah. Or just change the example slightly then. Say I have a service with this name label that identifies the pods that form that service.
Yes.
And I want to take a pod out of service, but keep the pod running. So I'm going to change the name label to be like, foo out of service. So this is quite common if you've got a misbehaving pod to just alter the label to take it out of service whilst still leaving it debuggable.
Gotcha. Okay.
So then the metrics from that pod will stop appearing in these queries, right?
You would still get the metrics because the pod name, as long as the pod name's still in the query.
Well, the pod name label I've changed, so it wouldn't be right.
The pod name you've changed?
So I have on all my pods, I have a label called name, just to confuse people.
Yeah.
Let's call it something else. Let's call it the service label.
Yes.
And so if I change the service label to take that pod out of that service, service is also confusing. I have a label called foo.
Yes.
I
And-
use that label to identify the services, identify the pods that are part of that service. So like foo equals bar, that's all the pods in the bar service. Yeah?
Yeah.
Now I change that to be bar dash out of service to take that pod out of that service, but still leave the pod running so that I can debug it.
Okay, so this would be a situation where I imagine if you have that service indicated as like something you're using to specify like the filter for the pod list, it would probably disappear if you refresh the page because it would look at the Cube API and be like, oh, this pod does not have this annotation foo equals bar or whatever, and you would not see it. But then you could change it to the new one, and it would.
Yeah, but I'm
find
more
it.
worried about like the previous version, before I changed the label, those metrics would have been included in that graph, and now they're not.
Yeah.
So I mean, we advise people explicitly not to do this in Prometheus, right? We advise people to scrape the cube pod labels time series and then do a join at query time, because that deals explicitly with this case.
Well, I think that would be more of an issue if you're doing like alerting or analytics based on it. But if you're doing it just in a visualization in real time, I don't think there's I don't see how that would be that big of an issue, because you would be able to. I mean, every time you refresh the page, I mean, like if the label's changed, then the pod shouldn't be in the query.
Well, I mean, it should be for when the pod existed with the right label, and shouldn't be for now when the pod exists with a different label.
Yeah.
I mean, it's about historical data.
Well, it also would depend too on when you refresh the dashboard. It would stay.
Well, I mean, that's even worse, right? I mean, I deploy things like every few minutes.
Yeah.
When literally every single time a PR goes in, my services are redeployed, and when I'm really hacking away, that can be, every few minutes. And so then, I mean, if it's only when you refresh you fetch these labels, then the new pods that get launched wouldn't be included in the metrics, and the graph would just tail off.
But if you're querying on that label, then why would you expect pods without that label to exist there?
Well, they do. Have that label.
But the label's changed.
Well, no, the pods have gone away, or new pods have replaced them. I mean, I just think like you have
Oh,
to treat.
wait. Are you saying that if you replace the pod, like if you replace the label and then a new pod comes in to replace the old pod in the same label?
Yes.
Yeah, that would work. The new pods would be there.
So yeah, so I'm going back to the original case where I've just done a rolling upgrade. Maybe we should take this offline. This might be a bit.
Yeah, that probably.
Yeah, I'll let someone else ask a question. I'll come and follow up later.
Yeah. Yes.
So this is really just more of a general Grafana Labs question, but where does this type of development of these kind of dynamic querying integrations fit with other things that you're doing? And will you be doing more of that sort of thing, or is it just because you have a large Kubernetes footprint internally? I'm just curious about that.
A large part of working on Kubernetes and making dashboards for Kubernetes is driven internally because we use it. But at the same time, we have a lot of people use Grafana to monitor Kubernetes, so we just want to create tooling that can help people out and make things as easy as possible. In terms of like a company goal, I wouldn't be the right person to ask. Oh, I don't think. I mean, in terms of like Kafka integrations, we probably could do something. I wouldn't know what we would do though. I'm not sure. Yes.
Question about picking metrics based on SLA that you mentioned. I think the biggest issue that we had with that is that some pods never been scheduled for whatever reason, either limits or affinity or something else is wrong. So that metrics are good for pods that are normally scheduled and running and everything is sort of good and you can just only measure some performance, but not when bigger issues is happening.
So
with the environment.
I think there's metrics that are available that will give you errors for pods starting from the Kube State Metrics exporter. That might be the right place to look for if you're having issues with pods not starting or pods crashing. So those would be a good place to start if you're looking for something to alert on to get an idea of when things aren't necessarily running correctly or pods and containers aren't starting as planned.
Well, we did find the solution by querying API and getting metrics that we want. Just my concern is that you were promoting standardization and use the same kind of notations everywhere. But if you start to scrape ourselves and use
Okay, so I think I see what you're saying. So the best way to solve this, if there's a gap in terms of metrics available for figuring out when pods aren't starting in Kubernetes, that's definitely something that would be handled best in Kubernetes or in the API or in kubestate metrics really as a place to figure out like where that metric can be added, where that shortfall can be filled.
Thank you.
Yeah.
I'm going to follow the question that kind of was asked already. How extendable is Kubernetes integration in case like we want to do something that's like effectively asset management, like short-term asset management in a way, because you're pulling subset of metadata, some set of metrics based on different attributes that doesn't exist in time series. Like if we would kind of want to take whatever you did for Kubernetes and migrate to different type of service, like Yarn, for example, or something like that.
I'm slightly confused by the question, but let me see if I think you're trying to say. So like so if you're extending Kubernetes, how easy is it to migrate to a service similar to Kubernetes?
Not Kubernetes, but like this plugin that you showed that shows a bunch of stuff.
Oh, like how the JSON, like how to build plugins for Grafana, that's
This kind of one.
It's
like
really easy actually, and like more people should do it. If you wanted to like take this plugin and then re-implement it for your use case, I promise you it's not that hard. And if you want to talk to me more about it, just join our Slack channel and reach out. My name's Jay Lisi on there. If you know JavaScript, the barrier to entry is pretty low. The plugins load statically. You just put them in the plugins directory that is generated when you start Grafana, and it will kind of figure itself out. To be fair, like some of the documentation is kind of weak, and there's definitely room to improve. But if you're looking, especially if you're just looking to add like template queries, like if you don't want, like if you're not trying to build a time series database data source, you're trying to just build like a template query data source, that's really easy, and I can definitely help you out with that. Does that help? Yeah. Sorry, no, there's a light right behind you. I can't see anything. So, is there any other questions?
He was giving the thumbs up.
All right.
Perfect.
Yeah, I think that's it. Thank you.
Sounds good.
All right, everybody. We made it to the end of day one. Congratulations. So a few housekeeping items before I set you loose on the bar across the way. So the first is we will be sending out a survey via email at some point in the next few days. So we'd really appreciate any feedback that you have about the talks, about the format of the event, anything that we can do to improve these. We're going to be doing a lot more of these, obviously, all over the world. So there's that. The other thing that I was reminded to bring up is IFQL. There are two different ways to actually get it installed and play around with it. The first is there's a Docker Compose in the IFQL repo. So if you have that, it will actually spin up an InfluxDB and an IFQLD, so you can play around with it. We also have something called Sandbox, which is just influxdata/sandbox on GitHub, and that will actually spin up the entire stack for you, including IFQL, so you can play around with that. Workshop day is tomorrow. It's included with this, so if you want to go, you should come. You can just talk to them at the desk across the way. What that'll do is it'll make sure that we order the right amount of, or we have lunches and all that stuff covered. So we're updating the format. So the schedule basically says it's like 2 tracks where there actually is like training and everything. We are going to do 3 tracks for tomorrow. It's in this building. It's on the 2nd floor. But we're going to do 3 tracks. One is basically a beginner's track where you can learn the basics of the different parts of the stack. One is for more experienced developers. I'll be doing an IFQL session at the very beginning of the day. And then the 3rd track is basically just a hacker's track. So after my IFQL session, I'll be hanging out in that. Probably a lot of the other Influx Data developers will be there as well. So even if you didn't want to attend like a workshop session, the hacking track is basically a good way to just hang out and talk to the super smart people that actually write the software. I'm not in that crowd. I basically just to talk about their awesome work. So what else? I don't know. Then I have the next set of slides. Yes. So the next Influx Days will be in London on June 14th. I think June is a delightful time to visit London. Maybe we'll get the one good week of weather that London gets per year. So please join us for that if you can. So the other thing we're doing this year is we want to, and we've wanted to do this for like years, but the idea was we wanted to start a set of meetups that are devoted to time series data. So we're just calling them time series, whatever the location is. So this year, or about 4 or 5 months ago, we started building out our developer advocacy team, and we have 4 people who are actually all here today. So we're going to be running meetups every month in San Francisco, and the format is some talk about time series data. It may or may not be Influx related. There's no requirement for that. If it's interesting to anybody who is doing monitoring or they're building applications on time series, things related to infrastructure, to analysis, to algorithms, to visualization, it's fair game to have a talk at this meetup. So it'll be on the same day every month in whatever the location is: San Francisco, New York City, Raleigh, and Denver. Denver's on the list as well. And then as we add more people to the team, we'll be rolling out in other locations. But if you live in a city other than one of these 4, and you're interested in doing these meetups, we will help you do it, and we will provide gifts for you. So if you are interested, please talk to us. We'd love to start kicking off time series meetups basically around the globe where people can talk about building applications around time series. All right. There it is, what you've been waiting for. The bar is past the elevator bank, right over there. And hopefully you'll hang out and have good conversations. Thank you so much, everybody.